Now, the last part to this chapter is redox. Within redox, you must know some definitions. The first one being oxidation number. Oxidation number is the number of electrons involved in bonding of any kind of bonding. Oxidation numbers are based on a set of rules. The first rule being that the element or elements on its own or on their own is always with an oxidation state of 0. Number 2 is that for ions, example being iron 2 plus, magnesium 2 plus, their oxidation number is equal to their ionic charge. This means that for something like FeIII, which is Fe3 plus, it will have an oxidation state of +3. For FeII, which is an ionic charge of Fe2 plus, it has an oxidation state of +2. Now, the last rule is on the periodic table, the oxidation numbers are as follows. Group 1 is +1, Group 2 is +2, Group 3 is +3, Group 4, you cannot put a number on it. Group 5 is -3, Group 6 is -2, and then Group 7 is -1. Now, there are certain exceptions to this rule. The first one being that hydrogen, which is normally +1, when bonded with metals, it becomes -1. An example of this being NaH. Sodium is +1 and hydrogen becomes -1. Now the second exception is oxygen is usually -2, but when in H2O2, it becomes -1. Lastly, fluorine is always -1, no matter what. Fluorine will always be -1. Now, this is not really an exception to the rule, more so a rule itself. Now, here are some examples that we'll go through together. SO2. We know that SO2 has an overall charge of 0. We know that oxygen will have a -2 charge, and there are 2 oxygens, so there's 2 -2s, which is -4. Therefore, to get 0, S must be +4. There you go. S on its own, 0. NH3. We know the overall charge is 0. We know that hydrogen will be +1, +1, +1. Therefore, it will be overall +3, and nitrogen must have a -3 charge. SO32-. We know the overall charge is -2. We know that oxygen is -2. We know there are 3, so there's -2, -2, -2, which is overall -6. And carbon must be +4 to get the overall charge of -2. Now doing the same thing to this, we know MnO42- has an overall charge of -2. Oxygen is -2, 4 times. Therefore, overall charge of -8, meaning this magnesium must be +6. Now, here is a good question for you guys to try. Calculate the oxidation state of Fe in all of the following. So, 0, -1, -1, -1, -3, drops down, must be +3 to equalize that. FeCl2, 0, -1, -1, -2, therefore must be +2. Here are 2 very good examples as well. MnH2O6. Now I will do C, and I'll give you guys an opportunity to do magnesium, and then I'll go through that one as well. So this is +2. We know that oxygen is -2. We know that hydrogen is +2, and we know that these both occur 6 times. So this is -2 6 times, so oxygen will have a -12 charge in the end. And then +2, because hydrogen is +1 and that happens 2 times, will also be a +12 charge. Therefore, these equal out to give you 0, meaning Fe must have a +2 charge. Now it's good for you guys to attempt this one yourselves, and then we'll go through it together. So the total charge is +2. We know that oxygen is -2 on its own. We know hydrogen is +1 on its own, which occurs twice. So +2 there. We know that these two occur 6 times. So this is -12. This is +12. Therefore, manganese, must be +2. Now, lastly, redox reactions. The definition of a redox reaction is reactions that involve both oxidation and reduction. Now, oxidation and reduction can be described in 3 terms. Number 1 being oxidation and reduction in terms of electrons. This is oil rig, which I'm sure many of you have heard already. Oxidation is loss of electrons, of course. Reduction is gain of electrons. In terms of oxygen, it's purely oxidation is the gain of oxygen. And reduction is the loss. And in terms of oxidation number, oxidation is an increase in the oxidation number, whereas reduction is the decrease in oxidation number. Now, number 1 comes up a lot in A2, so we will cover that when the chapter comes up. Number 2 doesn't necessarily come up and is not necessarily examined in any specific way. However, number 3, oxidation number, is extremely important for AS. So, oxidation and reduction in terms of oxidation number. To answer a question like this, where it asks you to show oxidation and reduction, we must first write all the oxidation states. So doing so, we have copper as 0 because it's standalone. We have NO3 as -1 because NO3 minus is a polyatomic ion. Therefore, silver must be +1 because the overall charge is 0. We have silver on this side being 0 because it's standalone. Then we have NO3 minus as -1 again, but Cu here as +2 because there's 2 NO3 minuses and the overall charge is 0, so Cu must be +2. Step 2 would be to identify the increase or decrease. So, if I just write the arrow there, we know that copper on this side has increased to +2. And we also know that silver on this side has decreased to 0. Meaning that this is a reduction and this is an oxidation. And leaving it at that, of course, specifying in the end, oxidation is Cu from 0 to +2 and so on. That's obviously required in a real exam question. However, just like this, working it out is all you do. Now, here's a question for you guys to attempt. Okay, we're doing this together. We know that aluminium is 0 because that is standalone. SO4 is SO4 2- because it's a polyatomic ion. This is -2. Then hydrogen would of course be +1 because there's 2 of them as well. We know SO4 remains SO4 2- here, -2. And there's 3 of those, so that's -6. And there's 2 here, so therefore aluminium here must be +3. And then the hydrogen, 0. Now going from aluminium here to there, this is obviously oxidation. And then hydrogen from here to here is reduction. The last thing on this chapter is disproportionation reactions. This is when a species, one species in a reaction is simultaneously oxidized and reduced. Now we can see this in this equation where we know from the previous rules that oxygen in H2O2 is actually -1. Therefore, hydrogen must be +1. Oxygen here is 0. Oxygen here now becomes -2 again, and hydrogen remains at +1. Here to here, that was a reduction. However, here to here was an oxidation. Therefore, this reaction shows disproportionation because oxygen is both oxidized and reduced at the same time. That was all of chapter 4 for OCR A chemistry. I hope that really helped, and I hope you have fun revising.